All right, let's talk about something that's all around us, but we barely notice until it fails. I'm talking about the language that separates stuff that works from stuff that just falls apart. This is all about quality and standards, the invisible system that takes a cool idea on a napkin and turns it into a product you can actually depend on.
So let's start with a really simple question. What's the real difference between a cheap toy that breaks in like 5 minutes and a precision instrument, say a high-end watch that could last a lifetime? Well, it's not just about the materials. It's about having a really rigorous, well-defined system for quality.
So what is quality, really? It's not some vague feeling of, this is good. It's actually a really simple, measurable promise. Does this thing do what it's supposed to do? Does it solve the problem it was made for? If the answer is a solid yes, well, that's quality.
Okay, so to see how this all comes together, we're going to walk through 4 main stages. First up, we have creating the blueprint. Then we get to the moment of truth. After that, we'll cover building a trail of trust, and finally, we'll look at the ultimate payoff. Let's get started.
All right, first up, creating the blueprint. This is all about defining the rules of the game. Before anyone even thinks about making anything, you've got to define, in excruciating detail, exactly what done right looks like.
And the absolute cornerstone of this blueprint? It's the specification, or spec, as everyone calls it. The best way to think about it is like the product's DNA. It's this super detailed document that lists every single technical requirement. We're talking dimensions, materials, functions, literally everything.
Now, a standard, that's a little different. A spec is for one specific product. A standard is way broader. It's a rule that applies across a whole industry. It's the reason a screw made in Germany will actually fit a nut made in Japan, or, why any USB-C cable will charge your phone. That's a standard at work.
So what's driving all of this? The requirement. This is the bedrock, the fundamental need the product has to meet. It's the what. What does the customer actually need? What do the regulations demand? What must this thing do to be a success? That's the requirement.
Okay, this is a perfect way to see how these two work together. A standard is the general rule, right? Like, all our new devices are going to use USB Type-C. Simple. But the specification, that's the nitty-gritty. It says, okay, that specific USB-C port has to support 10 gigabits per second data transfer. See that? General rule versus the super specific detail.
And one last thing for our blueprint, tolerance. Because let's be real, nothing in the physical world is ever perfect. Tolerance defines the acceptable amount of imperfection. It's the wiggle room. So if a part needs to be 10 millimeters long, the tolerance might be plus or minus 0.1 millimeters. And anything inside that tiny range, it's considered perfect.
Okay, so we've got this amazing detailed blueprint. Now for part 2, the moment of truth. This is where the rubber meets the road. We take the finished thing and check it against the plan we so carefully made. Does it match up?
And this whole check follows a pretty simple but absolutely critical loop. Step 1, you inspect the product. Step 2, you look for any defects, and I mean anything that doesn't match the blueprint. And finally, step 3, you make the call. Is it a pass or is it a fail?
If that product nails every single requirement in the spec, boom, it gets the green light. That's an approval. It's good to go, ready for the world.
But if you find a defect, the outcome is rejection. Simple as that. The product failed, it doesn't meet the standard, and it's either got to be fixed or scrapped. This is basically the firewall that stops bad products from ever getting to the customer.
Now, there's a really important little twist here. Sometimes you have to break the rules on purpose. That's called a deviation. It's a departure from the spec, but, and this is the absolute key, it's formally authorized and planned before anyone starts making anything. It's a calculated, approved exception, not some random mistake.
All right, so we've checked the work, but how do you prove to everyone else that it was done right? That brings us to section 3, building a trail of trust. Because it's not enough to just do the right thing, you have to have a system to prove it.
And this system of trust is built with a few key terms you'll hear all the time. Things like procedure, documentation, record, audit, compliance, conformity, and certification. They all sound kind of similar, but they link together in a really logical way. Let me show you.
So here's how that paper trail works. You start with a procedure. That's just your step-by-step how-to guide. When you follow it, you create documentation. As soon as you save that, it becomes a permanent, unchangeable record.
Then, down the line, someone does an audit, which is basically an official inspection of all your records to make sure you're in compliance with the rules and in conformity with the standards.
And what's the end result of all this paperwork? Something incredibly powerful: traceability. This is the ability to take any single item and trace it, and every part inside it, all the way back through its entire history. And when we're talking about safety, think car airbags or the food you eat. Traceability isn't just a nice to have, it's absolutely non-negotiable.
So, that brings us to our final section, the ultimate payoff. We've gone through all this effort, the blueprints, the inspections, the paper trail. So what? Why bother? Well, because all of it delivers real, tangible value to you, the person actually using the product.
First and foremost, you get reliability. This is just the basic confidence that when you press the button, the thing turns on. When you start your car, it starts. It's that simple, crucial promise that the product is going to work as you expect it to every single time. It just works.
Next up, you get durability. This is all about toughness. Can the product survive being dropped? Will it work in the rain? Can it just handle the normal wear and tear of life over a long time? A quality product isn't just built to work now, it's built to last.
And finally, there's performance. This is where that original blueprint truly becomes reality. A great quality system makes sure that the speed, the power, the efficiency that was designed on paper is exactly what you get in your hands. It's the ultimate measure of how well the product does the job it was created for.
So if there's one thing to take away, it's this. Quality is not a feature. It's not something you just tack on at the end. It is a complete system, all the way from the first idea to the final product in your hands. So I'll leave you with a question to think about. When you look at this entire system, which piece of it do you have the most influence over?